Join us in this video as we uncover Camiguin's land cover changes using Landsat 8 and QGIS. We acquired Landsat 8 imagery for Camiguin for the years 2013, 2018, and 2023. Ancillary data, including a digital elevation model from the Shuttle Radar Topography Mission, roads, waterways, buildings, seaports, watercourses, tropical cyclone tracks, and subnational administrative boundaries, were also obtained. Atmospheric correction was applied to the Landsat 8 imagery to minimize atmospheric effects. 3 LULC classes, water, built-up area, and forest, were identified. 10 training polygons and 8 validation polygons were created for each class. Validation points were generated to assess the accuracy of 3 classification methods: minimum distance, maximum likelihood, and spectral angle classification. To assess the accuracy of our land cover classification, we tested 3 methods and found spectral angle classification to be the most accurate. This method achieved high overall accuracies across all years: 96.17% for 2013, 95.31% for 2018, and 97.70% for 2023. We therefore use this method to classify land cover in our Landsat 8 images. To model and predict LULC changes, we utilize the MOLUSCE plugin within the QGIS environment. This process involved a series of meticulous steps. We began by importing the previously generated LULC map into QGIS. Subsequently, the study area boundary was imported, and its coordinate reference system was verified and corrected if necessary to ensure consistency across all datasets. The ancillary data, serving as predictor variables in the model, were then imported. Each predictor variable was systematically converted into raster format. The extent of these predictor rasters was then adjusted to align with the study area boundary. To incorporate spatial relationships into the model, each predictor raster was transformed into a proximity raster, representing the distance of each pixel to the features represented by the predictor. To ensure that the analysis remained focused on the study area, each proximity raster was clipped using the study area boundary, effectively removing any data extending beyond the region of interest. This step was repeated for all predictor variables. With the predictor variables prepared, the MOLUSCE plugin was launched within QGIS. This plugin provides a specialized environment for LULC modeling and simulation. Within MOLUSCE, we assessed correlations between predictor variables. A strong positive correlation of 0.914 was observed between buildings and elevation, suggesting a tendency for urbanization in higher elevation areas. Moderate positive correlations of 0.676 between buildings and roads, and 0.615 between elevation and roads, indicated infrastructure development patterns. Analysis of LULC changes between 2013 and 2018 revealed a significant loss of forest cover, an expansion of built-up areas, and a slight increase in water area. A neural network was trained within MOLUSCE for LULC prediction. The training process resulted in a minimum validation overall error of 0.11239 and a validation kappa of 0.77886. Despite a slight drop in overall accuracy, the model demonstrated strong agreement between predicted and actual classes. Cellular automata simulation was employed within MOLUSCE to predict LULC for 2023 and 2028. Validation against the actual 2023 LULC map demonstrated an overall pixel accuracy of approximately 85.89%. Kappa statistics indicated fair agreement, moderate agreement in the proportions of LULC classes, and that spatial patterns were captured reasonably well. LULC prediction for 2028, generated using MOLUSCE, revealed projected trends: a continued decrease in forest cover, a surprising decrease in built-up area, and a significant increase in water area. These changes may indicate shifts in land use priorities, potential impacts of climate change, or other factors requiring further investigation. This analysis of Camiguin's land cover, using Landsat 8 imagery and MOLUSCE, reveals high classification accuracy and predictive insights for 2028. The findings highlight key trends, providing valuable guidance for sustainable land use and environmental planning. In the end, it's not just about data, it's about making decisions that truly matter for a sustainable future.